So I'm sharing my week 6 assignment. So the assignment was to solve a given problem. So the problem was to use this dataset ccpp underscore data.csv, and the problem was based on these parameters we have to predict the net hourly electrical energy output. So the parameters are temperature, ambient pressure, relative humidity, exhaust vacuum, and the values are given for these temperatures, and based on these values we have to predict hourly electrical energy output. Okay. Now these are the grading criteria. So what is the modeling approach? Okay, what is the model building, and how we have to how it is evaluated, and what is the model interpretation. So I have identified the modeling task as a regression task. So because we have to based on these parameters we have to predict the energy output. The features used I have already described. These are the features: temperature, ambient pressure, relative humidity, exhaust vacuum, and this is the target. Okay, the algorithm that I am going to try, I am going to try three algorithms. First is linear regression. It is the base to start with, and second is SGD, stochastic gradient descent regression. Both these are from sklearn. I've used sklearn implementation. And third one that I've tried is a simple deep neural network model. Okay, and the metric that I've used to evaluate the performance is mean absolute error. So MAE, it gives us a clear picture of the error in case of a regression task. So it is a good metric to use in this case. And then I have run these models already, so I'll show you the results. So first let me describe the structure. The ANN model and linear models are kept in different files. I have imported the data using pandas read CSV. Okay, and then I have divided into features and target variable, and I used sklearn train test split to divide the data into test data and train data. Now these are the copies that I've created of the actual data, just to avoid any corruption during the training. And then I have kept the linear regression result, SGD regression result, and NN model results. That is, this result actually is the mean absolute error returned by these respective functions, and then I have printed them. Okay, now linear model, you can see that linear model is the linear regression model. First one is, and I have used randomized search for our cross validation. So this is a function which is present in sklearn, so it can be directly used. It takes as input the parameter grid, which describes different parameters of that particular model and the possible values, and it will iterate through all these combinations, and it will find the best parameters which gives the best result within a time. Okay, now this is the fit function which is called for the training data, and then the best parameters are returned, and this is the mean absolute error. So it is the difference between the on test data it is calculated, so target variable and the predicted variable. So it is the difference between target and predicted variable. Okay, and same is done for SGD. Okay, these are the parameters on which we have iterated to identify the best parameter combination, and then we have returned the mean absolute error. Okay. For ANN, it is a simple keras implementation. Okay, so first is the normalization layer for input, and then we have created dense layers, two dense layers, and the output layer is a single dense layer, single neuron dense layer. Okay. And then the model is compiled with mean absolute error loss, and optimizer I have used is Atom optimizer. Okay. And I've tried AdaGrad as well. AdaGrad gives you know its performance is lesser compared to Atom, so you'll see the Atom result here. And this is the model. We are maintaining the history of the model when we are fitting it, so we can print that history. We can see a diagram of that history. I'll show you. And this can be plotted, right? Then the test results are taken using the evaluate function, and I've printed the test loss and returned the test loss, which is the mean absolute error loss actually. Okay, so we'll compare this test result, mean absolute error, with linear model results. Okay. So let's run it and see. It will take some time to run, and meanwhile we can see that this is done for linear regression model. Okay, and these are the best parameters find. uh, Same is done for in case of SGD. So this is the combination of best parameters, and this is the score, and we'll see the mean absolute error finally once we get the mean absolute error of ANN model as well. It will take some time because it is not using the GPU. So here it is. We can see that mean absolute loss is reducing, loss is reduced, and so has the validation loss, but in the end validation loss again has increased. So there is a great variation in validation loss, but overall it is converging. So we may run more epochs and we may see better result. Okay. Let's see what is. Yeah, so these are the mean absolute errors. Obviously in model mean absolute error, final mean absolute error has increased, so this is not a good model. We need to rework on this. Let me change the epochs. So let's see what we can do. We can increase the number of epochs. Let's make it 800. Okay, and yeah, now I'll run it and now we'll see the results. Yes, so we can see this is the result of 800 epochs now, and I hope the validation loss has reduced a bit compared to the previous iteration. Let's see the results. Yeah, so it has improved slightly, but again it is, compared to the base model, it is still more. So what I feel is like if we increase epochs a bit more, so we may be able to improve the performance further. We can try more epochs and get better results.